Okay, let's give you guys some practice. So here you've got two cars that are 100 meters apart. Two cars 100 meters apart. So this is 100. This car is accelerating to the left at 3 meters per second squared, and then this car is traveling at a constant speed at 7 meters per second. So in 1 second this car would travel like this. 1 second it would have done 7 meters. And another second, 7 meters, and so on. It would travel like this at a constant speed. This car here would travel like this. 1 second later, it would have done this distance. Another second, it would have done a bigger distance, and another second later, it would have done a bigger distance because it's accelerating. So this car will travel in this manner. This car will travel at a constant speed. Eventually the two cars will crash. They will crash somewhere in between. Your job is to work out this distance at which they crash. Work out x. Okay, so work out x where they will crash. So press pause and have a go. Okay, so to do this, draw the three graphs for each car. So this car's we'll draw the acceleration time graph. The acceleration will be 0. Draw the speed time graph for this car. It will look like this, because 1 second later the car would have done 7 meters. The speed will be 7, and another second later the speed will be 7. Another second later the speed will be 7. It will look like this. The distance time graph for this car will look like this, and then for this car, the acceleration will be 3. That means the speed will be 3t, and then the distance time graph will look like this. Is a quadratic, because you've got t squared here, and the distance time graph will look like this. Now the hard part is to come up with an equation to describe the precise point at which the two cars will crash. So the hard part is in coming up with the equation to describe the crash. Now, do you really care about the speed time graph? Do you really care about the speed at which the two cars will crash? You don't really care. What's interesting is the distance time graph of the two cars. You see, this car is traveling like this, and this graph here describes this distance, and this car here, this graph here describes this distance. The hard part is in coming up with the equation to describe the crash. You see, at the time at which the two cars will crash, if you get this distance plus this distance, it should add up to 100, because the distance that separates the two cars is 100 meters. So to describe the crash, you have to do it like this. Well, the distance traveled by this car is given by this. So it would be 7t, that's the distance traveled by this car, and the distance traveled by this car will be given by this, plus 3t squared over 2. That's this distance here. Now, at the time in which they crash, this distance plus this distance must equal 100. That's when the two cars will crash. So suppose let's just say, after 2 seconds, this car would have done this distance, and this car would have done, let's say, this distance here. You see, this distance plus this distance will not add up to 100. So the crash will not occur. If you get this distance plus this distance, and if you have the two together and it comes to 100, that's when the crash will occur. So the trick to solving this problem is to work out the time in which they crash. So really it boils down to you using this equation, 3t squared over 2 equals 100. So it boils down to us trying to solve this equation. Find the time at which the two cars will crash, that's this t here, and once you've got the t, put it into here, and then that will then tell you the distance traveled within the time of the crash. So it really boils down to us solving this. So let's continue from this point here. So to solve this equation is really a quadratic, because you've got t squared. This equation is really in this form, because you've got t squared here That's this thing here, and then you've got your t here, and then you've got your constants here. So really this equation is really a quadratic equation. So let's transform this into this. So here you've got two, looking at this, you've got two layers, 1, 2. Get everything onto one layer. So here you've got 3 blocks, 1, 2, 3. Times everything by 2. So times this block by 2, that will then give you this. Times this by 2, that will then give you this. Times this by 2, that will then give you this. So now you're here. Let's just rearrange it to get it into this form. So we've got x squared first. So we want to put this in front. And then put this in the second place. And then, well, here you take away 200. And then that will then take you to here. So you are now currently here. So you can see that this is now in this form. So now remember, we don't want the coefficient to be anything other than 1. We can't complete the square. Well, remember, in order to solve this, we need to complete the square. But in order to complete the square, the coefficient must be 1. So get rid of this 3. So here you've got 4 blocks. Divide everything by 3. So divide this by 3. That will then give you this. Divide this by 3. That will then give you this. Divide this by 3, divide this by 3. Remember, 0 divided by 3 equals 0. So it gives you this thing here. That will then take you to here. And then to complete the square, remember, I'm expecting you to be able to complete the square by heart. From here, your eyes should zoom into these two terms. And it's always going to be half of this coefficient. Half. So what is half of this? So 14 divided by 3. If you want half of it, then divide it by 2. But then it gets multiplied to the bottom. So really you've got a block of 3 times a block of 2. But imagine this this 14 as a block of 2 times a block of 7. So now these two just cancel out, leaving you with 7 over 3. Well, anyway, it's going to be half of this coefficient. That will then give you this. And then you take away the rubbish. The rubbish will be this. Squared. So if you think about it, if you look at this thing here, plus 7 over 3, and then you've got t plus 7 over 3. The rubbish will be this thing here, which will be 49, and then 3 times 3, which will be 9. I'm expecting you to be able to complete the square by heart. Okay, so this, and then carry this down. That will then take you to here. This is just a single number, merge these two together. That will then give you this thing here. That will then give you this thing here. So now once you're in this form, you can rearrange it to make t the subject. So rearrange it. Hang on. Rearrange it. So add this block to both sides. Square root both sides. So you get positive version, negative version, and then take away this. That will then give you this. So time equals this. So you're going to get two answers. You're going to get this thing, take away this thing, which will give you a negative answer, but we don't care about negative time. As far as we're concerned, we can't travel back in time. So we're going to discard the negative version of time and just consider the positive version. Well, the positive version would be 6.16. So the time at which the two cars will crash will be the time at which the two cars will crash will be 6.16. So the two cars will crash when t equals 6.16. So that's when the time will crash. If you want to find out this distance here, put this time into this graph. So 6.16. Where will this car be at time equals 6.16? So just put it into here, and then it will tell you the distance. It will tell you the distance right here. So put this thing into here. So it would be 7 times 6.16. So it would be 7 times 6.16. So the distance will be 43.12. So the two cars will crash at a distance of 43.12 meters. Okay, that's your final answer.